Sputnik 1. Sputnik 1 is the satellite that proved orbital flight was physically possible, and it did it with a radio transmitter, a battery, and a metal sphere 58 centimeters across, roughly the diameter of a standard basketball. It completed one orbit of the Earth every 93 minutes, at an altitude between 215 and 939 kilometers, transmitting a repeating radio beep detectable by amateur equipment anywhere on the planet. The signal carried no data beyond its own existence. That was sufficient. Its launch in October 1957 forced the United States to accelerate its own program, directly produced the founding of NASA, and shifted aerospace spending across both superpowers within months. Every satellite currently in orbit exists because this object demonstrated that the physics worked. Vanguard 1. Vanguard 1 is the oldest human-made object still orbiting the Earth, launched in March 1958 and still circling at an altitude between 654 and 3,969 kilometers, where it is expected to remain for a further 200 years. It weighs 1.47 kilograms and measures 15 centimeters across. Soviet Premier Nikita Khrushchev called it the grapefruit satellite as a dismissal of its scale compared to Sputnik. But Vanguard 1 outlasted every satellite that followed it for decades because of a single engineering decision. Alongside its battery-powered transmitter, it carried a solar-powered one, the first spacecraft in history to use photovoltaic cells as its energy source. Its orbital drift measurements revealed that the Earth is not a perfect sphere, but slightly pear-shaped, with the southern hemisphere bulging 45 meters further from the core than the northern. Scientists are now debating retrieving it as a historical artifact before its orbit finally degrades. KH-11 Kennan. The KH-11 Kennan is the largest and most capable reconnaissance satellite ever operated, and its specifications remain classified more than 40 years after its first launch in December 1976. What is known comes largely from declassified references and leaked imagery. The satellite is approximately the size of a school bus, with a primary mirror estimated at 2.4 meters in diameter, identical to the Hubble Space Telescope, which was built using surplus fabrication infrastructure from the KH-11 program. It was the first spy satellite to transmit digital imagery in near real time rather than ejecting physical film canisters to be caught by aircraft over the Pacific. Ground resolution is estimated at approximately 10 centimeters, sufficient to identify individual people from low Earth orbit. In 2019, a photograph released publicly was traced to KH-11 imagery, briefly revealing the system's current resolving capability to anyone with the knowledge to interpret it. The constellation allows intelligence agencies to monitor nuclear facilities, military deployments, and treaty compliance without any physical presence in foreign territory. Hubble Space Telescope. The Hubble Space Telescope launched in April 1990, carrying a primary mirror ground to a precision of 10 nanometers, and that mirror was wrong. A spherical aberration of 2.2 micrometers, roughly 50 times thinner than a human hair across its 2.4-meter surface, rendered every image blurry. The flaw was correctable because Hubble was designed from the outset for servicing by astronauts in orbit, a decision that saved the program entirely. In December 1993, a space shuttle crew installed corrective optics, and the telescope was restored to full function. It has since made over 1.5 million observations, calculated the age of the universe at 13.8 billion years, confirmed the existence of supermassive black holes at the centers of galaxies, and produced imagery that became the basis of public scientific understanding for an entire generation. It orbits at 535 kilometers altitude, weighs 11,110 kilograms, and points with an accuracy of 0.007 arcseconds, equivalent to holding a laser beam fixed on a coin 640 kilometers away. Navstar GPS. The GPS constellation consists of 24 operational satellites in medium Earth orbit at 20,200 kilometers altitude, each carrying between 3 and 4 atomic clocks, accurate to 1 second in 300,000 years. The system does not tell a receiver where it is. It broadcasts the time and position of each satellite, and the receiver calculates its own location by measuring the arrival delay from 4 satellites simultaneously. The clocks aboard these satellites run 38 microseconds faster per day than clocks on the ground, a combined consequence of reduced gravity and orbital velocity predicted by Einstein's theories of relativity. Without a daily correction, positional readings would drift by 11 kilometers within 24 hours. The system was declassified for civilian use in stages, with intentional signal degradation removed in May 2000. It now underpins global aviation routing, financial transaction timestamps, electrical grid synchronization, and maritime navigation. A sustained failure of the constellation would halt commercial aviation, destabilize banking infrastructure, and disable the timing systems that coordinate mobile networks across every continent. PlanetScope Dove. A PlanetScope Dove satellite is 10 by 10 by 30 centimeters and weighs approximately 4 kilograms. It images the Earth at 3 to 5 meter resolution and operates in low Earth orbit at around 475 kilometers altitude. Planet Labs built them using commercial smartphone components rather than aerospace-grade parts, accepting a shorter individual lifespan in exchange for the ability to manufacture and launch hundreds. In 2017, a single Indian rocket carried 88 Doves into orbit simultaneously, the largest single satellite launch by count at that time. The full constellation images the entire landmass of the Earth every 24 hours. That daily global revisit was previously achievable only by national space agencies operating multi-billion-dollar programs. The data stream is used to track illegal deforestation, monitor crop failures before they become food security crises, and document military movements in real time. The satellite that a person can hold in both hands is now doing work that no government constellation could match in coverage frequency. GOES 16 GOES 16 is a geostationary weather satellite positioned 35,786 kilometers above the equator, fixed over the Western Hemisphere and watching the same region of the Earth continuously. It produces a full disk image every 10 minutes and a targeted regional scan every 30 seconds. Its advanced baseline imager captures data across 16 spectral bands simultaneously, covering visible light, water vapor concentration, cloud top temperatures, and surface heat. Its geostationary lightning mapper was the first instrument in geostationary orbit capable of detecting individual lightning flashes through cloud cover in daylight, tracking storm electrification as a predictor of rapid intensification. In its first 4 years of operation, GOES 16 produced more total data than the entire archive of all previous GOES satellites, from 1975 to 2017 combined. Average tornado warning lead times increased measurably after its operational deployment because forecasters could see storm rotation developing before it reached the surface. It weighs 2,857 kilograms at launch and is designed to operate for a minimum of 15 years without servicing. Starlink V2 Mini. The Starlink V2 Mini weighs approximately 800 kilograms and carries a solar array spanning 13 meters, generating enough power to run 4 times the communications capacity of the original Starlink design. It uses argon-fueled Hall effect thrusters for orbital maneuvering, a propulsion choice driven by argon's abundance and low cost compared to krypton. The V2 Mini was an intermediate configuration, deployed while SpaceX awaited a rocket large enough to carry the full V2 design. More than 5,000 Starlink satellites are currently active, making it the largest constellation ever operated by a single entity. The network provides broadband connectivity at latencies below 40 milliseconds, and its terminals were deployed in Ukraine within days of the 2022 invasion, providing communications infrastructure to military and civilian users when ground networks were destroyed. Astronomers have formally documented the constellation's impact on ground-based optical observation, with Starlink satellites appearing in a measurable percentage of long-exposure images taken from every major observatory on Earth. International Space Station. The International Space Station is 109 meters across its solar array span, weighs 420,000 kilograms, and travels at 7.7 kilometers per second, completing 16 orbits of the Earth every day at an altitude of approximately 400 kilometers. Its pressurized interior volume is 916 cubic meters, comparable to the passenger cabin of a Boeing 747. It has been continuously occupied since November 2000, a streak that has survived rocket failures, geopolitical ruptures between its partner agencies, and 2 decades of equipment degradation. The Environmental Control and Life Support System converts urine and atmospheric condensation back into potable water, recovering 93% of all liquid the crew produces. Every month, atmospheric drag pulls the station roughly 2 kilometers lower, requiring engine firings from docked cargo vehicles to push it back up. Construction involved 16 nations, 36 assembly flights, and 218 spacewalks. Its scheduled deorbit in 2030 will direct it into the southern Pacific Ocean, where the structure will burn during atmospheric re-entry, and any surviving fragments will impact open water. James Webb Space Telescope. The James Webb Space Telescope cost $9.7 billion. Launched on Christmas Day, 2021, and spent the following 30 days performing 344 sequential mechanical deployments in deep space, with no crew available to intervene if anyone failed. Its primary mirror is 6.5 meters across, assembled from 18 hexagonal gold-coated beryllium segments that folded inside the launch fairing and unlatched in sequence after separation. A 5-layer sunshield measuring 22 by 12 meters, each layer thinner than a human hair, blocks thermal radiation from the sun, Earth, and Moon simultaneously, maintaining the instruments at negative 233 degrees Celsius. The telescope operates at the second Lagrange point, 1.5 million kilometers from Earth, in a gravitationally stable position that keeps the sun permanently behind the shield. At that temperature, in infrared wavelengths, it detects light from galaxies that formed 300 million years after the origin of the universe. Shortly after reaching its operational position, a micrometeoroid struck one of the mirror segments and left a measurable but non-critical deformation. There is no mechanism to repair it. It operates as built or it does not operate.